Hi everyone, it's Hari here with the Young Scientists Program, and we're back in the kitchen because the kitchen has tons of examples of the type of stuff we're going to be learning about today, specifically acids and bases. We have a couple examples right here in front of me, like oranges, which are known to be acidic, and also limes. Here's a piece of a lime, and if I look back here in the cabinet, we have baking soda, which is known to be basic as well. If you've heard of citric acid in citrus fruits like oranges and limes, you'll know that it can sometimes taste a little bit sour. Oranges might not have as much citric acid, but if I were to take a bite of a lime, there's a lot of acid present in there. Stay tuned and we'll talk about what acids and bases actually are and how we can tell them apart. So far, we have learned quite a bit about chemistry. We know about atoms, molecules, physical and chemical changes, and last week we talked about chemical reactions. Today, we're going to investigate a new chemical property, and that is whether a substance is either an acid or a base. Acids and bases are really important in the field of chemistry, so let's go over what they actually are. The best way to tell them apart is by looking at their characteristics, starting with an acid. The first characteristic of an acid is it probably tastes sour. If you've had anything sour before, there's a good chance it's an acid. Next up, acids can also sometimes react with metals to create hydrogen gas. Lastly, if you dip a piece of litmus paper in an acid, it'll turn the paper red. We will talk more about litmus paper when we get to our activity at the end of the video. Some good examples of acids are vinegar or juices like orange juice or lemon juice. Next up, we need to identify bases, and a lot of bases have similar characteristics as well. First, most bases taste pretty bitter, but remember, it's never a good idea to eat or drink anything you are working with for science. Bases also feel quite slippery, and lastly, if you dip a piece of litmus paper into a base, it should turn the paper blue. Some good examples of bases are baking soda, household cleaners, or soap. At the bottom of this picture, we have something called the pH scale. This is how scientists rank how acidic or basic a substance is. Lower pH levels from 1 to 4 mean the substance is acidic, whereas higher pH levels from 10 to 14 or so indicate that the substance is basic. If the pH is around 7, the substance is neither acidic nor basic, and we call that neutral. This week's Scientist of the Week is Rosalyn Yalow. Rosalyn Yalow was a famous chemist and physicist from the mid-1900s, and she won the Nobel Prize in Medicine in 1977. She had a groundbreaking process that allowed doctors to measure the chemical properties of liquids inside the human body, allowing them to look for vitamins, hormones, and other substances. She was able to use her chemistry expertise to understand everything in the human body, like whether certain liquids have to be a certain pH level in order to function correctly. Today, we will be testing quite a few liquids to see if they are an acid or a base. If you want to follow along with the activity, print out this worksheet linked in the description of this video. Let's get started. The substances we are going to be testing today are vinegar, baking soda mixed with water, lime juice, plain water, and a wet wipe. I'm going to pour a little bit of each of these into a small bowl and dip my litmus paper to see what happens. Litmus paper is a special kind of paper that changes color based on what liquid you put on it. From this chart, we can see what color corresponds to different pH levels. If the paper turns red, the liquid is acidic, and if it turns a dark blue or green, it is basic. If it stays close to yellow, the liquid is neutral. The first substance that we'll be testing is vinegar, and I'm going to pour a little bit of it into this cup. I'll take my pH test strip and dip it into the cup, and we can see almost right away that it turns red. When we compare that to the chart, the red matches the pH level of about 2 or 3, which means the vinegar is a pretty strong acid. Next up, we have baking soda, and I'll mix a little bit of it with water so it's easier to dip the pH test strip in. Once I get the test strip, we'll see that it turns a dark green almost immediately. Comparing this to the chart, this is around a pH of 9 or maybe even 10, which means that baking soda is basic. Our third test is going to be lime juice, so I'll squeeze a little bit from this slice of lime into the cup, and I'll dip my pH test strip in And again, just like the vinegar, it turns pretty red. Let's look at the chart, and we see that that red matches around a 3, maybe a 2, so lime juice is also very acidic. For our fourth test, we're just going to add some plain water and see what happens. With the pH test strip, there's barely any color change at all, and from the chart, that means it'll stay at around a 6 or a 7, which is neutral. Lastly, I pulled some wet wipes that we'll use as our fifth substance, and I'll take a pH strip and wipe it on the wet wipes, and we can see that the liquid from the wipes turns the strip pretty dark green. That looks to be around a 9 with a couple dark spots that could be a 10, which means the wet wipes are also just a little bit basic. And with that, we've finished our experiment for today, and that does it for our lesson on acids and bases. Hope you enjoyed and learned something new, and we'll see you next week. Thank you.